Lesson 4.9, System of Equations Word Problems. Systems of equations are actually really useful for many real-world applications. They can be used to solve business applications such as break-even point in production and sales projections. They can also be used to solve distance problems, for example, 2 trains leave the station, age problems, number problems, coin problems, mixture problems, percentage problems, and more. Word problems can be a little bit scary, but if we take them one piece at a time, they become more manageable. So first step is to read the entire word problem and identify the thing that you're asked to find. This is our unknown. Next, give the missing pieces of information a variable name. So this is letters, X and Y, or whatever letters you want to use. Using the variables you defined, write 2 equations based on the information in the word problem. And then solve the system of equations using one of the methods. And then make sure you answer the question that was asked and label your answer with the proper units. So here we have Smush Parker and Kobe Bryant are having a 3-point shooting competition. For each shot made, the player earns 3 points. For each shot missed, the player loses 5 points. After 40 shots, Kobe has no points. And we want to know how many shots did Kobe make. So we've got shots made and shots missed. Okay. So we can call, we're looking for Kobe's made shots. That's what we're trying to find. Okay, so that was our first step, to identify what we're looking for. Now we need to assign variables. We have made and missed. Well, those would both be M, so we can't use M for both of them. So I could say X is shots made and Y is shots missed. Okay. Your total points equals 3 points times the number of shots made, and you have -5 points times the number of shots missed. So this is your total points. Kobe has 0 total points. Okay. Now, X is the number of shots made and Y is the number of shots missed. This would be the total shots. X plus Y. Well, Kobe made 40 shots. So X plus Y in his case is 40. So we have 3 points times the shots he made minus 5 points times the shots he missed equals his total score of 0. And the shots he made plus the shots he missed is 40 total shots. So we want to solve this system. So I can use substitution, or I can use elimination, or I could try graphing, but this 40 makes this a large graph, so I'm probably going to not do graphing. If I wanted to do substitution, I could solve for X or Y and plug that in, or I can use elimination and multiply this equation by either -3 or +5 to eliminate the 3x or the -5y. I'm going to do the -3, and the reason I'm going to do that is because multiplying by -3 is actually not that difficult of a proposition, and I'm trying to make this as simple as possible. So I'll end up with 3x minus 5y equals 0, and -3x minus 3y is equal to -120. When I add these together, my x's will cancel, and I'll get -8y is equal to -120. I'm going to divide both sides by and y is going to be equal to 15. So he missed 15 shots. But we're not trying to find out how many shots he missed, we're trying to find out how many shots he made. So this is x is what we're trying to find. Well, I have x plus y is equal to 40. He missed 15 shots, so x plus 15 is equal to 40. Subtract 15 from both sides, and x is equal to 25. So Kobe made 25 shots. Okay, here's another type of problem that you can solve with a system of equations. We have the sum of two numbers is 24, their difference is 15. What are the two numbers? Well, I can say that x is number 1 and y is number 2. The sum of the two numbers is 24, so x plus y is equal to 24, and the difference is 15, so x minus y is equal to 15. Now this one, I have a positive and a negative y, so I can just use elimination addition. And I'll get that 2x is equal to 39. Dividing by 2, I will get that x is equal to 19.5. Now I know that x plus y is equal to 24. So if I plug in 19.5 for x, I subtract 19.5 from both sides, and I'm going to get that y is 4.5. Now you can double check. I say 19.5 plus 4.5, that's 24. 19.5 minus 4.5 is 15. These are both true, so my numbers are 19.5 and 4.5. Okay, let's try another one. Sally has 20 coins in her piggy bank, all dimes and quarters. The total amount of money is $3.05. How many of each coin does she have? All right, so we have D is dimes and Q is quarters. Okay, she has 20 coins, so all of the dimes and quarters together equal 20. Now the total amount of money is $3.05. Well, dimes are worth 10 cents, so we do 10 cents D, so the 0 doesn't really matter, but if you want to put it on there, you can. And quarters are 25 cents. Well, you add those together and you get the $3.05. So 0.1D plus 0.25Q is equal to 3.05. Now, we could get rid of the decimals if we want to. All we have to do is multiply by 100 and that'll clear out the decimals, or we can work with the decimals. I find that clearing out the decimals tends to make things a little bit more straightforward and mistakes are less likely to be made. So I'm going to multiply by 100, and the reason I chose 100 is because I have 2 decimal places. So that 100 is going to move the decimals 2 places. So what I'm going to have is D plus Q equals 20. That didn't change. And then I'll have 10D plus 25Q is equal to 305. Now I can multiply this. I can do substitution if I want, or I can multiply this equation by negative 10 or negative 25 to cancel the dimes or the quarters. I'm going to go ahead and multiply by negative 10 because that's easier. And I like to try to choose the easiest option, and it's easier to multiply by 10 than it is to multiply by 25. So after multiplying by negative 10, I'm going to get negative 10d minus 10q is equal to negative 200. And then my other equation gives me the positive 10d plus 25q is equal to 305. When I add these together, my dimes will cancel. I'll have 15q is equal to 105. I'll divide both sides by 15. And 105 divided by 15 is 7. So Sally has 7 quarters. We want to know how many of each coin she has. So dimes and quarters together is 20. She has 7 quarters. Subtract 7 from both sides. And she has 13 dimes. So 13 dimes and 7 quarters. Okay, let's try another. All right, we have here flying to Kampala with a tailwind. Okay, when you have a tailwind, so here's my little stick figure airplane. Okay, it's like an arrow, whatever. When you have a tailwind, the wind is blowing on the tail, and so your speed increases. If you fly into the wind, that's called a headwind. So when you fly into the wind, you're flying against the wind like this, so your speed decreases. Okay, so what we have is the speed of the plane is averaging 158 kilometers per hour with a tailwind. So this is the plane rate plus the wind will give us 158 kilometers per hour. Now on the return trip, so you have the plane rate minus the wind because it's going against the wind, so the speed is being decreased. You have 112. So what I'm going to do is I'm going to call the plane rate R, and then the W will be the wind speed. Okay, so I'm going to have R plus W is equal to 158, and R minus W is equal to 112. Since the W's are already assigned opposites, I'm going to get 2R is equal to 270. Dividing by 2, I'm going to get the rate of the plane is 135 kilometers per hour. But I want to find the speed of the wind also. So I have 135 plus the wind is equal to 158. If I subtract 135 from both sides, I have that the wind is equal to 23 kilometers per hour. So this is the plane and this is the wind.